drone, and this is me moments before I attempted to break the Guinness World Record for the fastest drone in the world. Last year my dad and I did something similar with the original Peregrine drone, but this year we're trying to take our drone to the next level and crush the competition that came before it. There are many different aspects of design when it comes to creating a high-speed drone, but I've decided to narrow it down to 4, which we will go through in this video. Which, by the way, was the most frustrating and difficult project I've ever worked on. The first design aspect is the frame. For our frame material, we went with carbon fiber because of its wide availability and incredible strength. We got our custom frames cut at Flying Robot in Cape Town using a CNC machine. Also, just a quick thank you to Insta360 for sponsoring this video. I'll be using their Go 3 camera to shoot loads of different parts of this video. So all the CNCing is finished, and you'll see we've got these really nice carbon fiber pieces. And the great thing about CNCing is you get really high precision. So you'll see that these motor mounts for the holes line up perfectly with the actual mounts on the motor. We did get the mounting hole dimensions wrong on these CNC cuts, so I'm out here in the garage to drill new holes. I love how the Go 3 is magnetic, which makes it super easy to mount to a bunch of random locations and get some really interesting angles. The second design aspect is the powertrain. This is obviously an incredibly important part of the drone because it's what pushes it through the air. Using the darts we gathered from Peregrine 1, I was able to select the ideal motors, propellers, and batteries to use for Peregrine 2. This year the theme is simply bigger is better. Now it's time to do a bench test with all of our chosen components. And yep, on our very first bench test we had our first fire of the project. And the first time we got smoke, it actually came from one of the batteries. And I was so certain that this battery must just be a dud that we ran the tests again and another battery smoked. So clearly that isn't the case. I've actually taken the battery apart here to see what happened. And as you can see, here's the burnt portion. It just carried so much current that it got so hot and couldn't handle it that it just broke apart there. So I've opened the second battery here and you can see it's failed in the exact same spot as the first battery. We ran the thermal camera on these batteries and found they were getting above 130 degrees Celsius. Way too hot, so no wonder they were popping. Just a reminder, you can't always trust companies' claims about what their products can handle. After trying to work around the heat for weeks, we managed to get new batteries and thankfully these stayed below 80 degrees Celsius at full power draw. With our batteries not cool enough to fly, we found another issue. Our motor wires were getting suspiciously hot during full load. Eventually, during one of our bench tests, the motor wires even burst into flames. So, as we have now very dramatically learned, the wires that come installed with the motors are not quite thick enough for our application. So what I've done here is I've got a little experiment, and I've got the original wires, then I've got one thicker and one more thicker. As you can see, the thin wire got so hot that it desoldered itself from the ESC. Clearly too thin, so we opted for the wire with medium thickness. Now that we had dialed in our powertrain for the drone, it's time to move on to the third aspect of high-speed drone design, the aerodynamics, starting with stability. So one of the big problems we had with the first drone was instability when it was going at really high speeds. So what we've done now is we've actually created this little half-scale rough model of the new design, and we've got detachable tails on the end of the drone. So on here's the short tail, and then we've also got a longer tail. And to record the testing, I'm going to attach the Go 3 to the car so that we've got really good footage to analyze the tests later. By allowing the model to spin around the center of gravity, we were able to check if the center of pressure is behind the center of gravity to get an inherently stable shape. It turned out to our surprise that neither the short nor the long tail was stable. The drone kept settling on this weird angle. So we played around with some fins on the back, which seemed to provide enough force to keep the drone pointing straight. We then further refined the model and tested more fin sizes to create our final shape. This left us with an outer shell that we knew would provide stability and a low drag coefficient. My dad drew up the model and then we 3D printed and assembled it. So I'm finally finished putting the drone all together, and we've got the finished model over here. As you can see, it is quite a lot larger than the version 1. So we've just come out to this field and we're just gonna do some test flying, give it its maiden flight. Well, in case that wasn't obvious enough, that didn't go as well as planned. After contemplating giving up the project for about 15 minutes, the only thing left to do was to reprint all the parts and rebuild the drone from the ground up. After a couple days, the drone was fully rebuilt and ready for a successful test flight. This is the face of a man whose work from the past 2 months literally just went up in flames. Twice. It was during this time when my dad and I needed to wait a couple weeks for new electronics to arrive that we decided that we were going to completely redesign the whole drone body. We didn't feel good about what we had done so far and saw many ways we could improve it. My dad has made a separate video on his channel going through the entire design process and what choices he made when designing the drone, so definitely go and check it out after you finish this video. What we were left with is this, the official design for Peregrine 2. And of course, we did our classic car window test to check for stability. We then 3D printed all of our parts using the Bambu Lab X1 Carbon. I have to say this is the best 3D printer I've ever used, and it did an incredible job with this project. I'm genuinely looking forward to all the awesome things I'll print with this thing in the future. I do also love watching these time lapses it creates. They're super mesmerizing to watch. Our new design was printed, built, and ready to fly. Which brings us to the fourth and final aspect of high-speed drone design, the tuning. Things started out looking positive, but soon took a turn for the worst. We were having a lot of issues during flight, and to help fix this, we turned to the help of Chris Rosser, a well-known expert and YouTuber in the field of FPV drones.
So having looked at the video that you sent over to me, this is something that I've seen before. It would help me if you could answer just a couple of questions to help me diagnose the problem. If you bring your drone around other drones, does it have trouble socializing with the other drones? Do you find that it tends to bully or make fun of the other drones for being weak and pointless?
Yeah, actually, now that you mention it, it has actually been showing that kind of behavior.
I mean, this is something that we do have to deal with in the industry sometimes. It just becomes used to all this attention, all this praise, oh, you're the fastest, you're the best. And it just gets a little bit too arrogant. You basically get spoiled drone syndrome. This can lead to it attempting to do things that you don't tell it to do, attempting to do tricks that you don't want it to do, and basically just showing off.
So much sense.
Yeah.
Wow, I didn't even know that was a condition that they could get.
With any top athlete, it's a psychological game.
That's been really helpful to talk to you. Now I can see why they call you the drone whisperer.
These are problems that we will have to face in the industry.
All jokes aside, and after following Chris's advice and his in-depth tuning guides, we managed to get Peregrine 2 in top shape with an excellent tune for high-speed flying. So after literal months of prototyping, trial and error, and failures, we're finally back at the Woeste Gliding Club. And you'll probably remember this if you watched the first video. And what we're gonna do now is basically a high-speed run with no witnesses or anyone here, because we just wanna make sure that everything works 100% before we do the world record attempt. We've just got tape on here for now. That's gonna come off and gonna be glued on when we actually fly on the world record attempt. But as you can see, this is it all together and it's looking pretty sleek. We've got that clear tail at the end, which might look weird, but you'll see why we have a clear tail there in a bit. While we didn't get any failures mid-air, the drone was not as fast as we'd hoped in these runs. It only reached around 400 kilometers per hour, which is fast, but really not good enough. But we were not going to give up now. We decided to go for the timely and expensive option of replacing all 4 motors with ones of a slightly different kV value, as well as doing a few other aerodynamic improvements. So right now I'm sanding basically every surface of this thing so that all these transitions between different materials are smooth, so that these massive covers are smooth, and basically everything just needs to be as aerodynamic as possible. So the time finally came to see what this drone is capable of and what speeds we could get. The attempt has to be done with multiple independent witnesses. To get the final results, the 2 100-meter speed runs need to be performed in opposite directions to negate the effects of wind. 3 months of hard work, failures, and engineering would ultimately come down to a few seconds of high-speed flying. We are launching now. Oh my god! 500 kilometers an hour.
The 8420 for 50.
Yeah, we ready? And now I'm starting the speed run. So we finally heard back from Guinness and they've approved all of our results, which means we are officially